This is review problem number 3 for assessment number 4. In this problem, they want us to use the fundamental theorem of calculus to find the derivative for this function. We'll basically find the derivative for the integral. So we're going to find the derivative of this integral here. And to do that, basically the fundamental theorem of calculus tells you that when you take the derivative of the integral, right, they cancel each other out. And so you're going to see that this problem's answer is actually a pretty easy answer, but we're really going to focus on the algebra to get there. So if I want to find dy over dv, that means I'm finding the derivative of y, so I can write that as the dy over dv, and I think that's supposed to, dy over dv is going to equal the derivative with respect to t, or the derivative with respect to v of this integral here, 0 to v root 8 plus 9t squared dt. Alright, so that's the first step, saying that my derivative with respect to v is going to be equal to the derivative with respect to v of this integral. Now, we're going to do some kind of slick algebra moves here. So the first thing we're going to do is we're going to say that, alright, let's make this function t, f of t, is going to equal the inside function, which is root 8 plus 9t squared. And then I'm going to define that when I take the integral of f of t, that's going to be capital F of t, and we're going to call that the antiderivative of little f of t. So I think that's pretty straightforward, that f of t is going to be this integral and capital F of t is going to be the antiderivative of f of t. So we can go ahead and say that dy over dv then is going to equal the derivative with respect to v of the integral 0 to v of f of t, right? We can replace this root 8 plus 9t squared with f of t. So f of t dt. And then we can actually evaluate this integral, and we can say that this equals d over dv, and when we do the antiderivative of f of t, what do we get? We get capital F of t. So we can say that this is the derivative of this integral after it's integrated is f of t with 0 to v, right? We're evaluating that from basically v to 0, which we know that that equals, if we do the plug v in and plug 0 in, we would get the derivative with respect to v of, now, f of v, right, capital F of v, minus capital F of 0. So all we're saying here is that our original function, when we integrate it, we get this capital F of t, this different function, and we have to plug in our limits. There are our v and our 0, and now we're just going to take the derivative of this. Well, we know that the derivative of f of v is going to take us right back to little f. So this is going to be little f of v. We know the derivative of f of 0, well, f of 0 is actually, that's a number, right? So that's a constant. And we know the derivative of a constant is 0. So this is going to cancel out completely. So we're just going to end up with dy over dv equals f of v, little f of v. And we know that little f of v, well, that's just f of the f function with an input of v. So that's just going to change the t to a v. So that's actually just root 8 plus 9v squared. So that means that our derivative with respect to v is equal to the root 8 plus 9v squared. So the derivative with respect to v of this function, this integral, is just the same function, but with a different input value. Now in your assessment, that's an easy answer to come up with. But what we're really looking for here is we're really looking for all this algebra work and that you guys can work with the algebra.